Mid-shift, everything was running smooth until a loud bang, followed by dead silence from the pump room. Pressure dropped, flow stopped, and drilling came to a standstill. We were drilling ahead at 12,300 feet with steady returns. The number 2 mud pump had just come online after a routine inspection. Before we dive into the failure that nearly shut this rig down, it helps to understand the backbone of drilling operations, the mud handling system. RigPro Academy Real Incidents, Real Lessons Series. Understanding offshore mud handling systems. When you understand how this entire loop works, it becomes clear, a mud pump isn't just a piece of equipment, it's a vital organ in a complex, high-stakes circulatory system. To understand a mud handling system, we need to ask ourselves the following questions. Question 1. What is a mud handling system on an offshore drilling platform? Question 2. What are the main components of a mud handling system? Question 3. Last but not least, what is the function of the whole system? So, number 1. What is a mud handling system on an offshore drilling platform? A mud handling system is the heartbeat of every offshore drilling platform. It's responsible for circulating drilling fluid, commonly called mud, through the wellbore and back to the surface, while maintaining pressure, cooling the bit, and carrying cuttings to the surface. Number 2. What is the main components of a mud handling system? Let's break it down into key components. 1. Mud tanks, mud pits. These are large steel containers that store and condition the drilling mud. They're often divided into sections: active, reserve, and trip tanks. Each serves a specific purpose, from holding clean mud to separating gas or solids. 2. Shale shakers. As drilling fluid returns from the well, shale shakers are the first line of defense. They're vibrating screens that remove large cuttings and debris from the mud before it's recirculated. 3. Degassers. If the mud carries gas from the formation, degassers remove it to prevent blowouts and unstable fluid properties. 4. Desanders and desilters. These centrifugal devices remove finer particles like sand and silt that shale shakers miss. Keeping the mud clean reduces wear on equipment and improves drilling efficiency. 5. Centrifuges. Used for ultrafine solids control, especially in high-performance or synthetic mud systems. They spin at high speed to separate out very fine particles. 6. Mud pumps. This is the muscle of the operation. Large triplex or quintuplex pumps pressurize and circulate the mud back downhole via the drill string. If the pump fails, drilling stops. 7. Manifolds, valves and standpipe. Once pressurized, mud flows through a standpipe manifold system and into the Kelly hose or top drive, entering the drill pipe and heading downhole. 8. Return line and flow line. After doing its job downhole, cleaning, cooling, stabilizing, the mud returns via the annulus and flows back through a flow line into the solids control system. Number 3. The function of the whole system. Together, this system maintains circulation, controls pressure, and ensures safe drilling. It allows operators to detect kicks, remove formation fluids, and prevent blowouts. The following animation will clearly illustrate the entire mud cycle system from start to finish. Please watch carefully, and if you have any questions or comments, simply leave us a comment below, and RigPro Academy will respond promptly. The mud tank's aim is to deliver a sufficient volume of properly treated drilling fluid for drilling operations. Most mud tanks have mechanical agitators, mud guns, skimmers, and a mixing hopper to stir the drilling fluid and assist in solid suspension, additive blending, and uniform consistency maintenance. High-pressure rig pumps distribute drilling fluid throughout the hole. The pumps suck drilling fluid from the suction tank and pump it to the rig floor through the standpipe and down the drill string, where it exits the drill bit. The fluid cleans and lubricates the hole, cools the drill bit, and removes particles from the wellbore. As solids move up the annulus, they come into contact with the wellbore and drill string, causing friction. This friction on the solids produces finer particles, making it critical that the shale shaker and centrifuge remove them as soon as possible. The drilling fluid exits the flow line, enters the shale shakers, and runs over the shale screens. The shale shakers are the rig's major solids control system, capable of removing up to 75% of drilled materials. The effectiveness of solids removal is determined by the quality of the screens and the selection of the proper screen size for the solids to be removed. The drilling fluid, which contains finer particles smaller than the shaker screens, will pass through the screens and into the sand trap before overflowing into the shaker tank. The centrifuge feed pump pulls fluid from the shaker tank or sand trap and pumps it into the centrifuge. The lighter, cleaner fluid or effluent will flow back through the centrifuge's pool plates into the overflow pipes, returning to the rig's suction tank to continue the process. In this case study, we were drilling ahead at 12,300 feet with steady returns. The number 2 mud pump had just come online after a routine inspection. Within minutes, the crew heard a loud mechanical knock, followed by sudden flow loss and a 1,200 psi pressure drop. The mud pressure dropped, the flow stopped, and drilling came to a standstill. Initial inspection showed the discharge line was intact, but the pump itself had zero output. Once shut down and opened, the team discovered a shattered ceramic liner and severe scoring on the piston. The failure? A misaligned piston rod caused uneven wear over time, leading to liner fracture under pressure. The crew traced the issue to a misinstalled crosshead pin during recent maintenance. Without proper torque and alignment checks, the piston had been striking the liner unevenly. After 22 hours of runtime, it cracked under pressure. The pressure spike wasn't the cause, it was the trigger. The rig was offline for 9 hours. Spare parts had to be flown in. But we were lucky. If this happened during a critical formation or with compromised annular returns, it could have risked a total loss of circulation. What can we take away? Maintenance isn't just a checklist, it's a critical control. Small alignment issues become large failures fast, and we all share responsibility for catching them early. Want to avoid this on your next job? Learn from the real thing. Subscribe to RigPro Academy and make the next failure the one that never happens. Stay tight. In our next episode, we will look into another extremely important issue. Your experience begins with the appropriate knowledge. Thank you for watching RigPro Academy. See you next time.